Hi, my name's Tony Ross. I'm a program manager on the Internet Explorer team. Personally, I started building websites back in the mid-90s, and since then, I've started building browsers as well to help make the experience better for web developers as a whole. Since joining the IE team, I've had a lot of great opportunities to do just that. But today, I specifically want to talk about the topic of compatibility and same markup. Now, I know compatibility isn't necessarily the most glamorous topic, but at the end of the day, whether you're a user using a web browser, a developer building a site, or someone building a web browser itself, we all want fundamentally the same thing. For the sites we know and care about to just work. Now, part of this is up to the features that a given browser supports, but part of it also involves the code that a given site chooses to run in a browser. And that's really what the topics we're going to talk about today revolve around, the code that sites choose to run in a given browser. First, we're going to start by talking a bit about IE11, how it differs from IE6, why legacy code designed for IE6 isn't necessarily appropriate for IE11, and how changes we're making in IE11 make it easier for developers to just run more of their existing standards-based code on today's sites. Next, we'll move on to talk about how you, as a developer, can take control into your own hands for compatibility with building robust sites and apps that can stand the test of time and continue to work even as browsers and platforms constantly update. Last, we'll move on to talk about a set of tools that are available to you that can help you recognize issues in your sites and apply best practices so you know that you're building the sites that are going to last. Ultimately, what I hope you'll take away from today's session is to learn how to author robust sites and apps that continue to just work even as the web changes. This can have a number of benefits. While I know that on a schedule crunch, it can sometimes be tempting to just code to your test matrix and get something out the door. By focusing on building robust sites and apps, you can ultimately make it easier for your own sites to take advantage of the modern standards and performance improvements available across all modern browsers, while reducing your maintenance cost in the long term, because you'll have less instances of having to scramble to update your content as new browsers and platforms release. But first, let's get into talking about IE11 and how it compares to IE6. Now, as you're probably already well aware, Internet Explorer supports modern standards. We've been, ever since IE8, with the introduction of CSS 2.1, each version of IE since has been pushing the bar forward with the set of modern standards that it supports, ranging from SVG in IE9, CSS3 features like transitions and animations in IE10, and now 3D support via WebGL in IE11. But this is about more than just a couple of features every release. Over the past few releases of IE, an enormous amount of standards-based APIs and behaviors have been introduced into the platform. A lot of this was started with IE9, continued to be built upon with IE10, and in IE11, in addition to adding 3D support with things like WebGL, we continue to expand on other areas in the platform with support for features like Proto from ES6 and HTML5 dataset. When you look at all of these features, it's easy to understand how, to some extent, IE has advanced faster than the web has had a chance to adapt. Let me show you what I mean. In the IE6 days, there were a lot of different APIs that predated the modern standards we're used to coding to today. And as developers continue to support a wide variety of browsers and versions, a lot of these APIs still get used in today's code. The challenge is that how this code is chosen to run in a particular configuration. For example, window.attach event has since been replaced by the W3C standard add event listener, which is available in all modern browsers, including IE9 and up. But it's often strongly associated with the notion that a browser is IE. And so even when modern standards are available, a fair amount of existing web content will still choose to use legacy APIs like attach event just because they're running in IE. A similar thing can happen for a number of other APIs. One other example is using the CSS opacity property, which had a legacy equivalent in the filters property. Now, this isn't to say that such sites don't have standards-based code. In fact, most of them do. The difference is that they're not necessarily using it even when the support's available. And often, they're gating that decision of which code to run based off of the identity of the browser, for instance, if it's IE. And so while you may have add event listener or opacity or other modern API support like Canvas built into your site, it really is the choice of the code that runs that influences it just as much as the support for the API in the browser. Now, the interesting thing about these types of decisions for which code to run in which browser is that in practice it means that sites can end up running legacy code and mixing it with modern support for standards in different browsers. This can have unexpected and potentially undesirable results. Let me show you what I mean. What I'm going to open up here is a demo we actually originally authored back in the IE9 timeframe to showcase some of the patterns of browser detection that we were seeing in real-world sites. Now, I'm opening this up in Internet Explorer 10, and here what you'll see is that while most of the page renders well, there is a blank space for some content to go here. Now, you may already be aware that IE has a number of different compatibility features, and as a quick fix as a developer, you may be tempted to think about throwing this into a compatibility mode for something like IE7. If I go ahead and do that, it does in fact mean that the page works, and I can see my content. But what I really want to understand is why the content's missing in IE10's latest mode. I know that I've authored my page with standard support available that IE10 also has, so why isn't it taking advantage of it? As we dig over to look at the source code, what we see immediately in the script here is that up front there are some checks for browser identity. Specifically, this particular script has checks for both Internet Explorer and Firefox. Now, the checks themselves aren't that bad. In fact, they could just be used to gather browser usage statistics or something of the sort. But what you see later is that they're actually used in this page, in this script, to influence the behavior of which APIs are chosen to run in which browser. In my case, under one of the checks for IE, I'm actually calling an API with a known deprecated behavior. In IE9, the create element API was updated to no longer support angle bracket syntax in order to align with the latest standards and the behavior in other browsers. In fact, if you were to feed this same code to Chrome or Firefox, they'd break in the same way. And so it's really not here about what capabilities are available in the browser, but instead what code the site is choosing to run. Overall, the point I want you to take away from this is that modern browsers really do need modern code in order to run the web effectively. Part of this certainly is about the features and the standards which the browsers themselves support, but part of it really is about what code sites choose to run in a given browser. Now, let's talk about what we're doing in IE11 to help make this better and easier for developers. The first and most visible change is in the IE11 user agent string. If you're familiar with the old IE user agent string at all, you might immediately notice that there are some familiar tokens that are missing. Specifically, we've done some cleanup and removed some tokens that are no longer necessary, like the compatible token. But more importantly, we've also removed the MSIE token. Why? Because this token is a key piece of identifying information that has been used and strongly associated with legacy IE behavior. It's one of the top reasons that sites will choose to run legacy code instead of modern standards code and behavior, even when they have it available. By removing this token, sites don't choose to run those legacy code paths, and IE can actually get more modern standards code. Now, another piece you may notice is that there are some new additions. You may already be familiar with the Mozilla token that's common in basically every modern browser that's out there. You'll find Mozilla 5.0 in Chrome and in Firefox, as well as in multiple versions of IE. But now we've also added a Gecko token. If you look around at the different user agent strings, you'll see the Gecko token is also present in Chrome and most flavors of WebKit, and in Firefox as well. In a way, it's another one of those de facto tokens that has become necessary over time for browsers to have in order to get the latest and greatest content from websites. Now, since we have removed the MSIE token, we've also added the RV token to report the current version of the browser. Additionally, this follows a format similar to what other browsers have done. Now, this isn't to say that IE is masquerading as another browser or trying to be undetectable. In fact, IE11 can still be uniquely and easily identified. Part of this is through the Trident token, which has existed since IE8, and is a way to identify the real version of IE regardless of any compatibility settings that might be in use. If you're doing something like trying to track browser usage statistics, this is likely the right token for you to look at in order to figure out what browser and what version of IE is visiting your site. In the case of IE11, the value associated with it is always 7.0. But client side, if you're trying to alter behavior, ideally you would go off and use something like feature detection. But if you need to look at the user agent string for one reason or another, the combination of the Trident token and the value from the the RV token can actually allow you to uniquely identify both the version of IE and the mode that it's running in. Now, updating the user agent string addresses one part of the problem, but the reality is that in practice, browser detection takes many forms, extending well beyond just the user agent string. In particular, a number of APIs are assumed in the web to be strongly associated with a given browser or version. In the case of IE, these can range from things like document.all to window.attach event. Some of these checks are particularly creative. One of my favorites is the use of the conditional compilation feature to take a false value and convert it to true right before it gets assigned to a variable, so that in versions of IE that support conditional compilation, that is IE variable gets set to true. As part of helping IE11 get and run more modern standards code and making it easier for developers to take advantage of the standards capabilities that are available, these types of checks need to be updated as well. In a number of cases, legacy APIs and behaviors, in addition to the user agent string, have been either disabled, removed, or hidden to help make this happen. One of these is conditional compilation itself, much like conditional comments were disabled in a previous release. The legacy attach event API, which has since been replaced with the standardized add event listener, available since IE9, has also been removed. And even things like document.all have been updated to return false within an if check, even though the API is still available to access the properties on directly. Document.all in particular is quite interesting because that behavior isn't just something that we imagined. It's defined in the HTML5 standard, and it's implemented in the same way across browsers. Every browser, every modern browser, from IE to Chrome to Firefox, has a document.all that behaves in this same way, that's falsy, so to speak, but actually still functional. Now, with these changes, the question you might be asking at this point is, what does that mean for how IE11 interacts with my content? Let's go back to the demo we were looking at a moment ago and take a look. So this is that same demo page we were looking at in IE10, now opened in IE11. Default settings, no legacy modes or compatibility view applied. What you'll immediately notice is that it just works. The content is immediately available, and I, as a developer, didn't have to do anything to dig through my old types of browser detection and checks to update them. IE11 just made it work. Now, specifically, this happened because of the user agent string change. As you saw earlier in the source code, this particular script is using the notion of the user agent string to determine the identity of the browser and then applying that to alter behavior. Since the MSIE token is no longer present, It doesn't run the legacy workarounds for older versions of IE, and therefore the site runs the modern standards behavior in IE 11 and just works. And that really, in effect, is the main point. Not only does IE 11 support even more standards-based APIs and behaviors, building on the progress made in previous releases, it actually runs more of the existing modern standards-based code available on today's web, giving both users and developers a better experience. Now that we've talked about the changes we're making in IE 11 to help more content just work better, I want to move on to talk about how you, as a developer, can actually take control of the compatibility of your own sites and build robust sites and apps that can stand the test of time. I know that as browsers are frequently updating these days, it can often feel like you're constantly in a struggle to patch your site as the next version gets released and constantly testing to make sure nothing has been broken. But there are patterns you can take and approaches you can use to make sure your content will continue to work and has the best chance of continuing to work even as new versions of browsers are released and platforms update. Fundamentally, if you remember nothing else, take away this. By targeting behavior that is both standard and stable, you have the best chance of avoiding future compatibility problems. Now, by standard, I mean something that's actually been written down and agreed upon, so you know what you're authoring to. By stable, I mean something that's actually been implemented in various different browsers consistently, so you know not only that that behavior is agreed upon, but everyone can implement it, and it is a stable target that's less likely to change. Because all browser implementations are ultimately converging over time and trying to align with each other's behavior and documenting that in the standards bodies as they go. By targeting behavior that is consistent across browsers, you have a stable platform to build on without necessarily having to have deep insider knowledge of the depths of all of the different standards available. Now, looking at this another way, you can look at the sources of pieces of your code that can actually introduce compatibility risk into your sites. One of these we've talked about so far is browser detection, which can take the form of looking at the user agent string, or even vary to be checks against given APIs like attach event. But really, anytime you have alternate code paths, you potentially incur this sort of risk, whether you're providing different content, utilizing different features, or fundamentally taking advantage of different behaviors. It's those alternate code paths where you get away from what's necessarily stable and run into potential compatibility risk in the future. Now, of all of these things, browser detection truly is by far the most common source of compatibility issues we've seen, even across browsers, not just within IE. Because whenever you write a check that ends up applying, regardless of a version of the browser, some set of legacy behavior, you're applying that into the future, whether or not the browser ends up supporting or fixing that behavior, or adding some piece of standards-based functionality later. Now, to understand why, let's take a look a little bit at how browser detection is structured and how it works. Fundamentally, browser detection is comprised of blocks of code that are aligning with your test matrix, which is around the set of known browsers you've likely tested for while building your site. In effect, it creates these silos of code. So while you're making decisions about an event model versus how to style something, you group those things together based on the identity of the browser. Now, this works fine so long as the browser that your users are visiting with actually support capabilities and behavior that lie within that test matrix. Then you end up with support and a decision that lies completely within one of the pillars of that silo, and everything just works. The risk is that as browsers evolve, the different pieces of unrelated functionality may not evolve at the same time. And what can happen is that you end up with capabilities that are outside of your test matrix, where you may have a legacy piece of support and behavior in one place and a modern piece of support and behavior in another. For instance, if you had a browser visit your site in this example that supported the legacy IE event model, but had modern support for opacity, browser detection has no way to connect the dots between the two pieces of behavior, even though all of the fundamental capabilities needed to run your site well are available. Now, that isn't to say browser detection can't be used safely. In fact, so long as you're targeting legacy versions of browsers where the behavior is known and when the behavior was fixed is known, you're generally safe. So if I update this check to say, okay, well, if IE is less than 9, then I should use attach event and style.filter instead of add event listener and style.opacity, which I know were added in IE 9 and up. It's really the unbounded and versionless browser detection that introduces the real risk because you don't know what the future will hold. Of course, better yet, you can avoid browser detection entirely by using feature detection. Instead of gating your decision on which functionality to use by the identity of the browser, you can base it on what's available and align your code to the currently supported features where it's running. It's a simple change in checks such that if I want to know which event model is available, I look for add event listener, and if it's there, I use it. Note that it's important that I'm testing for the standards-based API first, because I want to make sure that I'm taking advantage of the latest and greatest features available in any given browser. If it's not available, I'll fall back to attach event. I can do a similar thing for my opacity by checking to see if it's available, falling back to filter if it's not. Important to keep checks local so that you can avoid accidentally including unrelated dependencies within a given check. Now, just because you're using something like feature detection doesn't mean everything is necessarily going to work perfectly. Anytime you are introducing alternate code paths where you're running something different in different browsers, especially if you're making different decisions and behavior across the latest versions of browsers, you incur risk. Part of that really comes into play based on the extent of the branch. Even if you're using feature detection up front, if you continue to use the different branches to apply different and potentially unrelated behavior, you might run into problems. For example, here we've made a decision on the event model, but we actually end up using different ways of inserting content into the page afterward. It's probably not even necessary. So if you can get back to the common code and minimize the overall size of the branch, you can reduce this type of risk. Here, I only branch for as long as I need to do the event registration, and when I go to insert something into the DOM, I get back to common code and just use append child. Now, better yet, I can look for a cross-browser alternative that works so I never have to have the code branch in the first place. Say, for instance, the reason I was using add event listener was simply because I wanted to listen for the load event on the document. And I knew that it's the only handler my page is going to register. I don't have to have support for multiple handlers at once. Well, then I could just go and use window.onload, which is also standardized, but it's been supported across a wide variety of browsers and versions for much longer than any of the other approaches. So it's a more stable target to build to. Not to say the other one is wrong, just that this one's better, depending on my particular scenario. And then I end up with no code branches at all, which reduces the amount of code I'm having to maintain overall, and I'm targeting standard and stable code, so I know the platform's far less likely to change out from underneath me in the future. In particular, this holds strongly true often for CSS-based layouts, where there can be many different ways to achieve the same effect using different technologies. Now, with these types of practices, people tend to think of them as being useful when they are deliberately targeting and testing and developing for multiple browsers. But the reality is, even if you're building for a single implementation of the web platform, be it on mobile or in some type of application, testing across multiple implementations can still reduce your maintenance costs long term. Because it's that testing that really helps you identify what pieces are stable in the web platform, so you know which APIs and features to use that are less likely to change out from under you in the future. So now that we've talked about the changes that IE 11 is making to help make things just work easier, and what you can do as a developer to take control of your own compatibility, let's look at some tools that can help make identifying and applying these best practices even easier. The first of these is the Modern IE site. This is a great resource that, in addition to containing cross-browser best practices about just general code for different versions of browsers and responsive design, also has a really useful code scan you could run by entering the URL to your site, which will kick up and raise to your attention potential issues. Lastly, it also makes it easy for you to create or download VMs for various different versions of IE, so you can go test on the real thing of each version to know how your content's going to behave. Complementing Modern IE is Compat Inspector. Whereas Modern IE's code scan is static analysis, Compat Inspector actually runs at runtime and analyzes how your code is executing within Internet Explorer. This allows it to provide deep analysis of issues. In addition to that, it can allow you to simulate on the fly making some of these fixes to your code so you can immediately know whether that's the only change you need to make in order to fix your content. And last, rather than having to search through an abundance of documentation about the changes in the platform, when Compat Inspector has identified an issue, it helps get you to just the piece of relevant documentation that matters to your situation. Let's go take a look at understanding how Modern IE and Compat Inspector can help us by applying them both to our demo site. All right, so as I switch over here, say I've been debugging my site in IE11 and I want to dig in deeper to understand what potential problems I might run into. The first thing I'm going to go do is open up F12. These are the new developer tools we've introduced in IE11. And as I move over here, there's an emulation tab I can dig into. This lets me do different things like experiment with different resolutions, orientations, and send different user agent strings to sites to understand how they might alter their behavior. But specifically here, I'm actually interested in getting a piece of a little bit more information. And what this actually links me to is Modern IE that we just talked about. Immediately you can see I have a variety of different tools available to me, some in the cloud testing that I can do via Browser Stack. I can also go off and download virtual machines for various different operating systems and VM platforms. But what I'm interested right now is the code scan that I mentioned earlier. So as I move over to the scan web page section, you'll see I just have a big field here where I can enter any public web URL I want to go get a static scan of its source code and results about potential compatibility issues it might have. Now, since my particular test page is actually local to my environment, I can't enter the URL in here. But fortunately, Modern IE also lets me download the scan to run within my local environment. I've already gone ahead and downloaded the zip and set up Node.js so I can run it. You'll see I have the console here with it running on local port. Now, if I go ahead and I open up the local scan on my machine, I get this page where I can enter an URL, any URL I can access from my machine, and get the scan to run against it. So if I enter the URL of my demo and go ahead and tell it to scan, it'll quickly do a scan over the demo and come back with some results. Now, at this point, I have an option to submit the information up to the Modern IE service so I can get a view in the site of the different results and guidance it's going to provide. If I'm curious to see what will be submitted, I can just go ahead and take a peek right now and see kind of the raw data that's going to be passed along. Now I'm going to go ahead and ask it to create my report. This takes me back to the Modern IE site, but now has a report that's customized to my local piece of content in my demo. Now, as I scroll down here, you're going to notice we have some warnings for pretty much what we expected. There's a browser detection section right here. And it looks like there's also some ways I could probably improve my responsive web design. I'd encourage you, if you're interested in that topic, to check out Jacob Rossi's talk. For now, I'm going to dig into browser detection. And here, immediately, I have a bunch of helpful information from Modern IE. First, some information on what it found and why it's relevant and why it's important. Then I get tips on how I can use better alternatives like feature detection and even a link to the Modernizer framework, which helps make feature detection easier to apply to your own site. And if I need to go do some live testing, I have links here back to Browser Stack or to get the virtual machine downloads. This is great. Now, of course, if I had a live site and I wanted to do a scan on that, as I mentioned before, I can just go ahead and enter the URL right here. In this case, I'll just go do the Modern IE site itself. Now, as we might expect, Modern IE looks pretty clean and up to date. But even here, there can be some additional information for me to dig in and understand more. So as I look under the known compatibility issues, none were found in Modern IE, which is great. But I do have a link here that helps me get to Compat Inspector that lets me dig in more deeply. Now, as I mentioned before, Compat Inspector actually runs within IE. But if you don't have an instance of IE handy, you can scroll down to the bottom and you have an option to go ahead and run the Compat Inspector code scan in the cloud in an instance of IE using the Sauce Labs automation. For now, I'm going to go ahead and we're going to take a look at Compat Inspector itself. Now, what you'll see here is some documentation for Compat Inspector. The important piece being that to get it up and running, I actually just need to add this piece of script to my page before any other scripts. I've already gone ahead and updated a version of my demo to have that. So as we flip over here, we can see the demo page plus Compat Inspector in IE11. Now, just to show where that came from, we can view source, and up top here is that script tag that was added. Now Compat Inspector is up and running the page, and I get a status widget up in the upper right-hand corner, where I can open up and investigate different issues it may have uncovered. Unsurprisingly, we have a warning about using navigator.useragent. Now, I can verify alternate behavior here, but since I'm running in IE11 already, I'm not really expecting anything to change, and it doesn't, because IE11 made the site just work. What I'm really interested in is digging into how I can make this site better for IE10. So going back to my IE10 VM, here we have our page again, and I'm going to go ahead and flip over to the version with Compat Inspector enabled. Now I get a little bit more information. Not only do I get the warning about sniffing the user agent, but now I also have a warning about the create element API. If you think back to the beginning of the presentation, this was the change in IE9 that I talked about for standards compliance and interoperability with other browsers, where it no longer supports the angle bracket syntax that wouldn't work in any modern browser. Now I can go ahead and quickly verify that behavior and refresh the page, and you'll see now even in IE10 and in IE10 mode, the content's working, letting me take advantage of more of the latest standards-based features available in multiple versions of IE. And the tool helped me do it. But of course, I'm still curious. As we mentioned before, it was more than just the create element piece that was important. It was really how we chose to run it. So in IE10, if I go and verify the user agent sniffing, the site works as well. And you'll notice I also no longer get the error for create element because the page is no longer attempting to run that code. And that's really the right fix for me to go and try to apply to my site. Now I'll go ahead and turn this back off so that we can see the original behavior. And the last piece I wanted to draw your attention to here is that in the message for create element, there's a link right off to the IE9 compatibility cookbook article. So here you can read more about what did change in the platform and get good code samples about alternate ways that you can achieve the same effect in all modern browsers. The right piece of documentation relevant to just the issue I was running into. Now, one last thing I'll go ahead and show here, since we have Compat Inspector up, is if I'm curious where one of these pieces of possible detection or issues occurs in my code, I can actually go ahead and debug it. So in the case of the user agent string, if I open up F12 and I go to the debugger, and now in Compat Inspector, I check the debug checkbox for that message. Go ahead and refresh, and I break into the code at a breakpoint triggered by Compat Inspector. As I look at the code that called it, what I find is I'm right in my code on that line where the check against navigator.userAgent occurred. And if I step over to the next instance, you'll see that I am now on the next line, where the check is checking to see if the user agent is equal to Firefox. So not only did Compat Inspector help me identify what the issue was and what the best resolution was, but it helped me isolate exactly where the problem was in my code, so I knew where to make the fix. Overall, what I want you to take away from Modern IE and Compat Inspector is that you do have tools available that make it much easier for you to test across multiple versions of IE and for you to support content that works well across multiple browsers and devices. So now we've gone from talking about how IE11 differs from IE6 and how the changes we've made in IE11 help more content take advantage of the latest standards behavior out of the box. We've also talked about the techniques you can use to build robust sites and apps that will stand the test of time as the web updates. And last, we looked at tools that you can take advantage to help make it easier to apply these best practices and identify issues in your own content. Overall, each of these themes really revolves around the notion of robust sites. And I encourage you to follow the best practices to build robust sites in your own content. This can help you reduce your overall maintenance costs and take advantage of more of the standards and performance benefits available in all modern browsers because you're using the best of what they have available. I definitely encourage you to go check out these resources to get Modern IE and apply its scan to your own sites, to use Compat Inspector to investigate any problems you might be encountering. And the compatibility cookbooks have a great wealth of documentation about the changes we've been making in IE release over release. That's all for this presentation, and I hope together we can continue to make the web better. Thank you.